So in this video, we'll talk a little bit about the gradient or the slope of a line segment. Right, so we have a line like so, and we know that it's a line because it extends both in both directions. And say we have our coordinate axes present like so, this being the x and this being the y. So this is a line right there. And the line is composed of many points. And if we choose 2 points, so and so, then the region between that is what we call a line segment. That is what we have included in our description of the gradient. So, by the definition of a gradient, we know that gradient of a line is a measure of its steepness. So we're talking about how steep or how high the line eventually rises when we go a certain distance in x. And by that I mean, if we have these 2 points for comparison to measure the gradient of the line, we are willing to go a distance delta x in the horizontal directions, and we want to ask ourselves, well, for that delta x, what is the height or delta y of the line? How much does it rise? As we have discussed previously, if this is x2, y2, and this point is x1, y1, then the gradient of a line is defined as delta y by delta x. Or in better terminology, if we have these 2 points, the gradient is then defined as y2 minus y1 divided by x2 minus x1. As you can see, that it is a measure that yields us the height of increment between 2 points when we choose to go a certain amount of distance. So, for a line, the other important characteristics rather of a line is that the gradient is held constant throughout the line. And by that I mean that gradient is a fixed value, a constant for a line. And if we want to measure g for a line, all we need to do is pick out 2 points, use their y values and their x values, put them in this form, and evaluate that ratio to get the value of g. So, say our line is like so, and it passes through 2 points. One of them is 3, 2, and the other one is 4, 7. And we want to ask ourselves, well, what is the gradient of this line? And in order to do that, we use the same description as before. Since these are 2 points, we first subtract the y components. So that's 7 minus 2 right there. And in that order, we subtract the x components. That's 4 minus 3. And after dividing that, we get a value of 5 divided by 1. And that is the value 5. So the gradient of the line is 5. That means if we choose to go a distance of 1 in the x direction, we end up rising a height of 5 in the y direction. Now, it may not seem like so in this diagram because the unit length of 1 here is much, much longer than the unit length of 5 there, but in contextual terms, this makes sense. We're asking ourselves, if we choose to move a unit distance in the x direction, how much height do we gain while traveling across the line? And that is what a gradient tells us. And as I said before, by measuring this ratio, we also get the steepness of the line. Now, this formula can be applied on any 2 points on the line. Say, if we have a point here in the third quadrant of, this is the first, this is the second, this is the third, this is the fourth quadrant of our rectilinear Cartesian 2D plane. If we choose this point to be in the third quadrant, and let us assume that the coordinates of this point are, well, -2, -3, and the coordinates for this point be, well, 4, 5. So we know that the line passes through these 2 points, and we choose one point which is in the first quadrant and the other point which is in the third quadrant. Let us evaluate the g for this line, or the gradient for this line. And we just need to apply this formula, keeping track of the signs in the right order. So the first point's y component is 5, and the second point's y component is -3, and we subtract them as it is. Similarly, we take the number 4, which is the x component of the first point, and we subtract -2 from that. Now, as two negatives become a positive, we get 8 there, and as two negatives also become positive in the denominator, we get a 6 there, which can be simplified as 4 divided by 3. So the gradient for this line is still positive because it increases in its height as we move in the x direction, and this is how we use the formula.